Hi class, today's lesson is lesson 4-1. It's on divisibility. Let's take a look at the purpose and copy this down. The purpose here is to understand the rules of divisibility. I want you at this point to go ahead and turn to the back of your composition books where we will write down three terms and the definitions to those three terms. The first term is divisible. You've heard this term before, but let's go ahead and define it solidly. When a number can be divided by another without a remainder. 30 is divisible by 15 in this equation because it gives us an answer of 2, a whole number 2, there's no remainder. 30 is divisible by 15. The next term is composite number. A composite number is a number that has more than two factors. For example, if we look at the number 4, we have a factor of 1 times 4, and we have a factor, so 1 times 4 is 4, and we also have a factor of 2, that is a part of that. 2 times 2, of course, is 4. So the factors of 4 are 1, 2, and 4. We look at 12. It also is a composite number. It has more than two factors. We, of course, have 1 and 12 because 1 times 12 equals 12. We have 2 and 6 because 2 times 6 equals 12. And we also have 3 and 4 because 3 times 4 equals 12. All these numbers, 6 numbers in all, indicate that 12 is a composite number because these are all factors of 12. Remember, a composite number has more than two factors. Let's look at prime numbers then. Prime numbers have exactly two factors, 1 and itself. The only factors of 3 are 1 and 3, exactly two factors. 1 times 3 is 3. There's no other whole numbers when multiplied together will give us 3. So exactly two factors here. 19, same thing. It's going to be 1 and 19 because 1 times 19 is the only expression using whole numbers that we can combine in a multiplication problem to give us 19. 1 times 19. Both 3, 19 are prime numbers. Here's some divisibility rules. Now, I will have given you this in class before you've seen this lesson, hopefully, so you can study those things, but we're going to go over this really briefly here. Some of these divisibility rules you'll know pretty well, and others are going to be new to you and are going to make you say, wow, that's cool. A number is divisible by 2 if the last digit is a 0, 2, 4, 6, or 8. That one you should probably know. This next one, number 3, a number is divisible by 3 if the sum of the digits is divisible by 3. In other words, if I add 3 plus 1, here it gives me 4 plus 5 gives me 9. So the sum of the digits of 315 equals 9. And since 3 plus 1 plus 5 equals 9, 315 is divisible by 3. It'll give me a whole number without a remainder. For number 4, if the last two digits form a number divisible by 4, then it is also divisible by 4. Here we have 8,512. The last two digits, 1, 2, 12. Does 4 go into 12? Yes. So 4 goes into 8,512 evenly as well. It is divisible by 4. For the number 5, a number is divisible by 5 if the last digit is 0 or 5. You should know that. Anytime you see a 0 or a 5 in the end of a number, you know it's divisible by 0 or 5, or divisible by 5. For the number 6, a number is divisible by 6 if the number is divisible by both 2 and 3. Look at 48. It's an even number, and since it's an even number, it can be divisible by 2. But in order for it to be divisible by 6, it also has to be divisible by 3. So let's take a look and see if it's divisible by 3. What do we need to do? Well, we need to add these digits. What's 4 and 8? 4 and 8 equals 12. And 3 goes into 12, so 3 is a factor of 48. Both 2 and 3 are factors of 48. Thus, 6 is also a factor of 48. For 9, if the sum of the digits is divisible by 9, this is much like, if not exactly like, the divisibility rule by 3. If these digits can be added together and are a multiple of 9, then this whole number is divisible by 9. Well, let's add 7 plus 1 plus 1 is 9. So 711 is divisible by 9 because 9 goes into 7 plus 1 plus 1, which is 9. 9 goes into 9. Finally, 10. If the last digit is 0, and you should all know this one, at least for a few years now, if the last digit is 0, then it's divisible by 10. 15,990 is divisible by 10 just by the fact that we have this 0 at the end. All right, it is actually a multiple of 10. Let's take a look at some examples that we need to work through. It says, tell whether 610 is divisible by 2, 3, 4, and 5. So I'm going to go ahead and write down 610 right here. All right, and I'm going to circle 2, 3, 4, and 5, 2, 3, 4, and 5, and I'm going to check the divisibility of this. Now, you don't have to write this table, but you do have to indicate what number we're working with in order to figure out the divisibility. For example, here we have 2. Is 2 a factor of 610? Well, we have to look at 610 and determine, is it an even number? And indeed it is. So we're going to say yes to 2 being a factor. For number 3, we have to add the sum of the digits. So I'm going to add the sum of the digits over here. 6 plus 1 plus 0, and that equals 7. Is 7 divisible by 3? No, it's not. So 610 is not divisible by 3. If the last 2 digits form a number divisible by 4, well, let's take a look at the last 2 digits of 610. The last 2 digits of 610 is 10. Does 4 go into 10? No, it does, not evenly. So we're going to go ahead and put down the word no. Finally, is it divisible by 5? Does it end in a 0 or a 5? And indeed, it does end in a 0, so we have to say yes to divisibility by 5. Second example, here we have the number 387. They want us to take a look at 387, and they want us to take a look at it at the 6, 9, and 10 factors, or possible factors. So if the number is divisible by both 2 and 3, well, is this an even number? And no, it's not an even number. So since it cannot be divisible by 2, it's not divisible by 6. So I'm going to go ahead and write a no. If the sum of the digits is divisible by 9, then of course 9 is a factor. Let's add 3 plus 8, which is 11, plus 7, which is 18. Is 18 divisible by 9? Well, yes it is. Therefore, 387 is divisible by 9. Finally, if the last digit is 0, it's divisible by 10. Well, you can plainly see 387 does not end in a 0, so it's not divisible by 10. Our last example is an example that deals with prime and composite numbers. It says, tell whether each is prime or composite. Remember, prime numbers have exactly 2 factors. Exactly 2 factors, okay? And composite have more than 2. So it's got greater than 2 factors. Let's take a look at this. With 45, I know that 1 and 45 are factors. I know that 3 goes into it. Wow, I already know 3 times what? Oh, 15. 3 times 15. So at this point, I don't even have to list all the factors. I know that this is composite because it has more than 2 factors. Let's look at 29. The only factors I know for 29 are 1 and 29. There are no other factors. So this makes this a prime number. Last problems are complete the problems. These are for you to do. For number 1, it says tell whether each number is divisible by 2, 3, 4, 5, 6, 9, and 10. Take that number through the divisibility rules. You might have to turn back this video to that page where you can tell. And then it says tell whether each number is prime or composite. And then it says explain. I'm going to be looking for that explanation as well. All right, we'll see you in class.